Hi, it's Carl Dubler with Imply. Back in the day, analytics systems weren't considered mission critical. I mean, if an executive dashboard went down, well, yeah, that executive didn't like it, but hey, at least your transactional systems kept running, right? Well, we can't afford to take such a relaxed attitude about reliability with analytics applications any longer because you're building these applications to track SLAs, to prevent customer churn, and maybe you're even selling analytics back to your customers within your software product. So downtime isn't going to be acceptable. You need nonstop reliability. So let's take a look at how Druid does it. To get an analytics system that runs no matter what, you need these four things: automatic backup, automatic recovery, automatic rebalancing, and rolling upgrades. So let's talk about how Druid does each of these things. Now, I've spoken on Druid's unique architecture on many other different videos, but we'll need to do just a quick recap here to understand how we get automatic backup and every one of these other things on the list. So Druid has an architecture that consists of independently scalable components like master servers, query servers, and data servers, data nodes. I'm just going to draw three of them here. Doesn't have to be three, there could be one, there could be thousands of these things. When data comes into the system, we store the data at this layer in segments. Now, I'll draw three segments here for that data node. This is where data is columnarized, compressed, partitioned, and indexed. Okay, yes, we do index data. So it comes into those segments there. And then once it's done being processed in those segments, then this is where the magic happens for this list. We write or we commit that data to deep storage, which could be in the cloud, for example, in S3, or if you're running on premises, maybe it's Hadoop. So data comes into the system, hits these data segments, and then is automatically committed to deep storage, which is a highly reliable storage layer that's not likely to go down. And this is how we get that automatic backup, okay? This architecture is really cool because I can get the query performance that you want from like a local shared nothing layer, but then because we have separate compute and storage layers here, it's also deep storage like you'd get in a cloud data warehouse. So you get that reliability and you get the data stored somewhere safe like that. So chances are this isn't going to go down, but other things could happen. So what about recovery? Well, every one of these data segments is replicated to another data node. If you have more than one data node, we'll replicate to that data node, or we can replicate several times depending upon how much protection you want there. So when it comes to recovery, what happens then is if you lose a data node, let's say this one, well, because it's been replicated to another data node, we just keep going. But what happens if you lose more than one data node? You also lose this data node. So now we have a real crisis on our hands here. Well, this is when our deep storage layer comes to the rescue, and we can rebuild those dead data or those dead data segments, rebuild what was on those dead data nodes on whatever's left on the other data nodes, and keep going. So this is how we achieve automatic recovery. Now, admittedly, this doesn't happen very often. You do want to plan for it, you don't want it to happen, but it's pretty rare. So what about something that's much more common, like maintenance scenarios when you're adding data nodes and doing upgrades? Well, the same architecture that gives you automatic backup and automatic recovery in Druid is here to help you with that maintenance as well. For example, let's say that you decide to add another data node. You're scaling out, which is what you should do if you need to process more queries per second, or you have more concurrent users coming in, or you're getting a lot of, say, millions or billions of stream events coming into the system. You need to scale out. Some of the very largest Druid clusters in the world that are handling millions of events per second might have thousands of these data nodes, but again, you don't have to have that many. It just depends on what you're asking the system to do. But let's say you do need to scale out. Well, with our competitor, one of our competitors, you're going to have to shut down the cluster and manually rebalance these partitions, manually rebalance these segments across the new data node structure here. We don't need to do that with Druid. We use the deep storage layer to automatically do that rebalancing, so you can scale out, or I suppose you could also remove a node and it would rebalance as well. So that is a major, major thing. When you're a growing analytics application, it's not just planning for unexpected downtime. It's planning for this kind of adding and scaling out. You need to have something that automatically rebalances without bringing the system down, and that's what Druid does. Same thing happens with upgrades. So if we need to upgrade the software, we can do this one at a time. We can just take that individual node and upgrade it, not bring the whole cluster down. So we can do a rolling upgrade. And again, we use the same technique that gave us automatic rebalancing and automatic recovery to aid in that as well. So Druid's just so unique. The way that it separates the compute for queries to a shared nothing layer, but then has this deep storage layer as well, you kind of get the best of both worlds, the best of shared nothing performance with the flexibility and recoverability that you would get out of a cloud data warehouse. And so if you can do all four of these things like Druid can, you too can have an application, an analytics application that runs no matter what. Well, I hope you enjoyed this short Druid Lightboard. I look forward to seeing you around the Druid community.